All right, folks, today we are going to look at the tangent function and the basic graph of the tangent function, and we're going to do a similar thing to what we did with the sine and cosine graph, which is to look at period length and talk about how it relates to the unit circle. And that's where we're going to start off with here. And let's first of all review what we know about tan of x or tan of theta. From our right triangles, we know that tan is y over x, and the circox or ticks, that's the ticks part of it. But we've also said on the unit circle that y values are the same as the sine values, and that x values are the same as the cosine values. So really, either way you look at it, y over x or sine over cosine, we can find the tan values at any one of these points on the unit circle. So let's start at the point 1 and 0. X over y, or pardon me, y over x would be 0 over 1, which is 0. That would be the value of tan. At root 2 over 2, it's something divided by itself. The value would be 1. And at 90 degrees, 1 divided by 0 is undefined. As we continue around, we will get negative 1, and then we will again get 0. As we continue around the unit circle, we're going to get 1, undefined, and then once again, negative 1, and then we're back to 0. So what you'll notice is that our values start repeating themselves right here, right at past pi. So our period length for tangent is shorter than it is for sine or cosine. It's pi, or it's 180 degrees. As soon as you get past 180, the values start repeating themselves. So what does that mean for our graphs? Well, here's a grid for us. We're going to split it up now. Instead of into pi over 2 with tan, we're going to use pi over 4 as our guide. And we're going to go to pi, and I'll go 1 past, so that would be 5 pi over 4. And we'll do the same thing on the negative side. And then we just start putting points on there from our unit circle. And I'm going to make this value here positive 1, and this value here minus 1 on the y-axis. Okay, let's get to it. So first of all, the value of 0, if we look back on the previous page, was 0. At pi over 4, which is the root 2 over 2, we got 1. At pi over 2, it was undefined. And so for undefined, we are going to draw ourselves a vertical asymptote. And we continue on. At 3 pi over 4 equals negative 1. At pi, it was 0. And then we start repeating ourselves again. We get 1. Let's go back the other way. At negative pi over 4, we got negative 1. And then with negative pi over 2, we had a undefined situation, which is an asymptote. At negative 3 pi over 4, we got positive 1, and then 0, and then negative 1. And seeing as how we have space, we might as well go ahead and draw the next point, which would be another asymptote right here, and then again right here. So when I go and connect the dots, you're just going to have to get used to what the shape of tan is. We could do more points and you would get the shape, but that's not really the point of the exercise or the section. You'll notice, whoop, my asymptote's in the wrong spot there. You'll notice that the shape is consistent. It's a periodic function in that it repeats itself, but it's not sinusoidal because it doesn't have that wave shape to it. You'll also notice that the amplitude here really isn't an amplitude at all because it doesn't have a maximum height or a low height. So that A value in front of tan is not going to worry about determining how high it goes, but it'll be where the value is going to be, or a key point for us at 5 pi over 4 or 3 pi over 4. And as the number in front changes, your number here will just increase and it'll make it look stretched out, and vice versa. If it gets smaller, it'll make it look compressed. And that's tan. And we'll work out the details together, and I'm sure that you will find continued success with the unit circle and drawing these trig functions.